My name is Alejandro Rodriguez, and I'm a doctoral student here at MIT in the physics department. I'm a Cuban national and immigrated to the United States when I was 12 years old. I spent 3 years at MIT doing my undergraduate in physics, and then now I'm a graduate student here in the physics department. My stepfather was a physics professor in Cuba. My mother was an astrophysics teacher, and it wasn't until my sophomore year in high school when I took my first physics course and I came back and I told my stepfather, look, I'm taking this physics class and it's amazing. Then he started opening up to me a little bit. Although my stepfather didn't directly speak to me about physics, he always challenged me intellectually and always posed questions to me that, again, I revisited in my introductory physics classes. And slowly, my passion, my love for physics started growing until I reached my senior year in high school, and then it was very clear to me that this was going to be my profession. I was also my junior year accepted into the MITES program, which is a program here at MIT for minority students who are interested in pursuing science and engineering. And it's an excellent program. It really does, it prepares you for college. It's designed for minority students to really get a heads up in not only physics, in many other fields.
Okay, so
let me show you exactly what we're thinking about right now. So suppose you have, so these are cylinders, right?
Yeah.
Instead of currents coming into the board, okay?
You want to make current loops?
Exactly. Academics not only, and physics in particular, not only helps you to excel at becoming an analytical thinker, but there's so many career opportunities in physics. Physicists can do law, physicists can be doctors, physicists can do engineering. Physicists are mathematicians. I mean, if you possess the basic tools you need to understand everything, then why wouldn't people want you to work for them? When somebody hires you for a job, they want somebody who can think clearly, who can think sequentially and analytically, and who can solve problems. And that is exactly the type of education you get when you go for a physics degree. I work in the condensed matter theory department. Condensed matter is the study of complex systems that form different phases, liquids, solids, and the interactions of many, many particles. What I study in particular is something called the Casimir force. Casimir forces are forces that arise between uncharged objects. If you put two parallel plates and they're uncharged, the laws of electrodynamics, of electromagnetism, tell you there shouldn't be any force between these plates. But in reality, people do measure a force. And this is called the Casimir force, and it arises due to what we call quantum effects. My curiosity is driving me to understand new things, but these new things that I understand can be the tools for something new and life-changing and can have social impact. And I definitely want to keep that in my list of to-dos.